Welcome back. This is Mr. Hassan's Maths channel, and I'm now going to be answering question number 3 from the June 2021 International A-Level Edexcel Statistics S1 exam. And this question here is all about histograms. We're told that a random sample of 100 carrots is taken from a farm and their lengths L centimeters recorded. The data are summarized in the following table. So there were 5 carrots between 5 and 8 centimeters, 13 between 8 and 10 centimeters, and so on and so forth. So this group data here says a histogram is drawn to represent these data. The bar representing the class 5 to 8 is 1.5 centimeters wide and 1 centimeter high. Find the width and height of the bar representing the 15 to 20 class. Okay, so basically the width of the bar, or the width of the bars, is determined by the interval, like 5 to 8, 8 to 10, 10 to 12, and so on. And the height of the bars is determined not by the frequency, but by the frequency density. Okay, and the frequency density is frequency divided by the class width. Okay, so the two things that we are interested in are the 5 to 8 bar. So the frequency density of this is 5 divided by 3. So I'll just write it as 5 over 3. And also 15 to 20 is the one we're looking at. So this is going to be 30 divided by 5. 30, the frequency divided by the class width. That's 30 divided by 5, which is 6. So that's the frequency density for the two that we are interested in. Those are the two that we're interested in here. Okay, so now what we need to do is to find the width and the height of this bar. So let's write down here the one that we're trying to find, 15 to 20. So I'll write this down on top because it's going to be the one that's with the unknown. And underneath, I'm going to write 5 to 8. That's the one that we know all about. Okay, I'm going to write down width and interval. That will help us find the width. And then I'll write down height and I'll write down frequency density. That will help us to find the height. So the 15 to 20, we don't know its width. So I'll just call that W, right? The width of the 5 to 8, okay, the width of the interval is, as they told us, 1.5 centimeters. 1.5 centimeters. And the interval, the interval for the one that we're trying to find is 5. And the interval for the one that we're given is 3. Okay, from 8 to 5 is 3. Okay, and for the height, well, we don't know the height of this bar, but we know the height of the other one is 1 centimeter. And the frequency density for 15 to 20 is 6. And the frequency density for the 5 to 8 is 5 over 3. Okay, so with this, we should be able to find what we need. Let me just get rid of this space here, make some bit more space. So now I can say that if I can basically use proportion. Okay, so this 1.5 interval with 1.5 centimeters is represented, or you can say an interval of 3 is represented by 1.5 centimeters. So an interval of 5 is represented by W centimeters. You can just use proportions. So you can say 1.5 times 5 over 3. And for the height, you can say a frequency density of 5 over 3 is represented by 1 centimeter. So a frequency density of 6 is represented by 8 centimeters. Again, we can cross multiply 1 times 6 divided by 5 over 3, and that will give us our answers. So we have 1.5 multiplied by 5 divided by 3, and that gives us 5 over 2, which is 2.5 centimeters. And the height is going to be 6 divided by 5 over 3. So 6 divided by 5 over 3, which is 6 times 3 over 5, which gives you 18 over 5, which is 3.6 centimeters. So we can see the width is 2.5 centimeters and the height is 3.6 centimeters for this bar that we're looking for. Okay, so it's just a simple proportion. So the width is determined by the interval. Okay, and the height is determined by the frequency density. So we can find we know the width of this is 1.5 given, and the interval is 3, and the interval of what we're looking for is 5, so we can work out what the width of that's going to be. And we know that the height of the bar that we're given is 1, and its frequency density is 5/3, and we know the frequency density of the bar we're looking to find, its height is 6, so we can again use proportion to find out that height. And we're done with question part A. Now for part B, it says use linear interpolation to estimate the median length of these carrots. Now, when you have grouped data, we don't have the actual details of the data. So I don't know exactly what the value of the median is. I know that there's 100 terms here. Okay, and as we don't know exactly what the median, each value is, when we're finding the median for this, or we're estimating the median, we just take n/2 to find the median position. So n/2 is going to be 50. So we're looking for the 50th term. Okay, so we look for the 50th term. We don't do anything like, all right, it's going to be, n/2, that's the 50th and the 51st term. And, we don't know what the 50th and the 51st term are. We just know what group they're in. Okay, so what we need to do is, we don't need to be as precise. We just say, okay, the 50th term. So what we do is we look to see in which group is the 50th term. So we kind of do a cumulative frequency. So what I'll do is here, I'll just make a little line to separate. Okay, over here, and I'll just say, okay, this is 5, then 5 plus 13 is 18, and then 18 plus 16 is 34. So now, by the end of this group, we're on the 34th term. 34 plus 25 is 59. Okay, so we're now in the 59th term by the end of this group. So we know that this is the group that contains the median. This is the group that contains the median. Okay, so the median is in the group from 12 to 15. Okay, so what I'm going to do, linear interpolation, is something which I like to make this little line to represent the group. So the group that we're in is the 12 to 15 group. Okay, and we're looking for the value of the median, which I'll call Q2. Now, by the beginning of this group, we're on the 34th term. By the end of this group, we're on the 59th term, and we're looking for the 50th term. We're looking for what is the value of the 50th term. So we can do something like this. We can say Q2 is equal to 12 plus. Now, I want to go along this, okay, a certain proportion. What proportion? This distance divided by that distance. So this is from 34 to 50, which is 16, and the width of this group is 25, as we know. Okay, so the fraction that Q2 is along this section here, the fraction that Q2 is along this section is the same fraction as the 50th term is along this section. So it's going to be 16 out of 25 times, and I multiply by this width here, because that's the width of this interval, times 3. And that should give us the value of the median, which we called Q2. So we have 12 plus 16 out of 25, 16 over 25, multiplied by the width of the interval, which is 3, and that should give us our value, which is 13.92. 13.92, that is the value of the median length of the carrots. Okay, so that's part B done. So there's part A and part B completed. Now we're going to go to part C. Part C says estimate the C part 1, estimate the mean length of these carrots, and C part 2 is estimate the standard deviation of the lengths of these carrots. So the mean length of the carrots, we can't find the mean, but we can estimate the mean, because again, we don't know exactly what the values are. So we know 5 carrots are between 5 and 8 centimeters, but we don't know exactly their lengths. So what we need to do is just say, okay, we got to take an estimate of the length of these 5 carrots. So what we do is we take the mid-interval value, which they've already done for us. If you 5 plus 8 is 13, divided by 2 is 6.5. So these are the mid-interval values which we need to multiply by each of these frequencies, and they will tell me, like those 5 carrots, I don't know how long they are, let's say they're 6.5. 5 times 6.5 will give me the length of these 5 carrots. And similarly for this one, you're going to have 13 carrots, I don't know how long they are. I'll take halfway between. So let's say the 9, so 13 times 9 will give me the length of these carrots. So if I make another table here for f times x, you're going to do 5 times 6.5, 13 times 9, 16 times 11, 25 times 13.5, 30 times 17.5, 11 times 24. And we know the total is 100 here because there's 100 of them. So if I add all these together and divide it by 100, that will be an estimate of the mean length of all those carrots. So I'll just write the steps here. So it's 5 times 6.5 plus 13 times 9 plus 16 times 11 plus 25 times 13.5 plus 30 times 17.5 plus 11 times 24, and all of that is divided by 100. And that will give me the mean length of the carrots. Okay, so let's just put that in a calculator. You have to be very careful here not to make a mistake. It's easy to just type the wrong number. 5 times 6.5 plus 13 times 9 plus 16 times 11 plus 25 times 13.5 plus 30 times 17.5 plus 11 times 24. All of that divided by 100. There's 100 items, and that gives us 363 over 25. I'll write it in its exact form first because we might need the exact form. 363 over 25, sorry. Be careful. So we can say an estimate of the mean is going to be equal to 14.52 centimeters. That's an estimate of the mean. Okay, so we found that. And then it says find the standard deviation. Now the standard deviation is basically the square root of the variance, which is the mean of the squares minus the square of the mean. Okay, so we've got to find the standard deviation, which is given by simple sigma, is equal to the square root of. Now the mean of the squares is basically where you square each of these mid-interval values and you multiply by the frequencies and then you divide by 100. Okay, you've got to find the mean of the square. So like, we take the square of each of those values and multiply by the frequency. So it's going to be the same as this, except these values are going to be squared. Okay, so it's going to be the same kind of setup here, except this will be squared, squared, and squared. So you have 5 times 6.5 squared plus 13 times 9 squared plus 16 times 11 squared plus 25 times 13.5 squared plus 30 times 17.5 squared plus 11 times 24 squared, all over 100. That's the mean of the squares minus the square of the mean. So minus 363 over 25 all squared. I could have written 14.52 because that's exact, but normally it's good to put this fraction in case that wasn't exact. And that is the standard deviation. It tells you how far. It tells you, basically the average the average distance, you could say, of the entries away from the mean. Okay, how spread out. It tells you about the spread of the data away from the mean. Okay, so the standard deviation is equal to this. So I've got to set this up in my calculator. Let's see if I can use what I've already got here. I think I can use this, what I've already typed in. I just have to just go back and change this 6.5 and make it squared. Okay, that'll work. 13 plus 9 squared. 13 times 9 squared, sorry. 16 times 11 square the 11. 25 times 13.5 square the 13.5. 30 times 17.5 square the 17.5. 11 times 24 square the 24. Divided by 100. Okay, that gives me 116 over 5, 1164 divided by 5. You have the square root of 1164 over 5 minus, and you got 363 over 25 all squared. So let me just calculate that. So I'm going to take away from that. I'll put in brackets 363 over 25 and square all of that. And then I need to take the square root of this because standard deviation is the square root of the variance. So the square root of my final answer there, which gives me 4.6871. So that's 4.6871. So we can say 4.69 centimeters is the standard deviation. So that's the answer for part 2 of C part 2. Okay, now it said a supermarket. Now for part D, a supermarket will only buy carrots with lengths between 9 and 22 centimeters. Estimate the proportion of carrots from the farm that the supermarket will buy. Okay, so we got to find between 9 and 22. So basically, it's going to be halfway between these two, and from 20 to 28, 22 is like 2 out of 8. That's like a quarter of the way along this section. So we're going to have all of those added together, plus a half of this, which is half of 13 is 6.5, plus a quarter of this section, because from 20 to 28 is 8. From 20 to 28 is 8. So 22 to 28, from 20 to 22 up to 22, that's like 2 out of a total of 8, which is a quarter. So you need a quarter of these 11 that will be acceptable. So a quarter times 11, that's going to be 11 over 4. Okay, so that's going to be like 2.75, isn't it? 11 over 4. 2.75, so you can say 2.75, just keep it in decimals. So that's 2.75 from here. That will be what we need. So we can say that the proportion of carrots, so you got to, out of the 100 carrots, you're going to have 6.5 plus 16 plus 25 plus 30 plus 2.75 out of 100. That will be the proportion of carrots that the supermarket will buy. So let's set this one up. So we have 6.5 plus 16 plus 25 plus 30 plus 2.75 over 100. So that's going to be 0.8025, 0.8025, or you can say it's 80.25% of the carrots, 80.25%. Okay, so that was you can say that's 80.25 carrots, okay, out of 100, which is 80.25% of the carrots. Okay, the proportion of carrots. You can write it as a percentage, you can write it as a decimal, as you wish. Okay, so that's part D. Okay, and now for part E, it says any carrots that the supermarket does not buy are sold as animal feed. The farm makes a profit of 2.2 pence on each carrot sold to the supermarket. Okay, so 80.25 are sold to the supermarket. All right, and then it says a profit of 0.8 pence on each carrot longer than 22. Okay, longer than 22. Okay, there was up to 22, there was 2.75. Wasn't that right? Up to 22, there was 2.75. That's right. So bigger than 22 is going to be 11 minus 2.75. So you have 11 minus 2.75, which gives you 8.25. So 8.25 carrots. So 8.25 carrots are being sold, okay, for a profit. Okay, so 0.8 pence. So supermarket, so that's going to be 2.2 pence. 0.8 pence, they're sold, the ones that are 8.25 out of those 100 are sold for 0.8 pence. And then it says a loss of 1.2. So these are profits. So these will be profits. And then it says a loss is going to be of 1.2 pence for how many carats? Shorter than 9. Okay, the ones that are shorter than 9. Okay, so you're going to have basically half of these, which is 6.5 plus 5. That's 11.5 of them. This is a loss. Okay, so the estimate of the mean profit per carat made by the farm. So we have 80.25 times 2.2. That's the amount that they gain from those 80.25 carats. Plus 8.25 times 0.8. They're selling these carats for 0.8 pence. Okay, those are profits. And then you got to take away 11.5 carats because they make a loss of 1.2 pence for each of those 11.5 carats. So you take that away. That will be the total amount of profit. Okay, that's like the net profit, because these ones will be profit, that will be loss. So you have to put them together, and that will give you how much they make per carat. Well, that's for the 100 carats. So of course you divide by 100, and that will give you the mean profit per carat, because there's 100 carats altogether. So now we're going to just put those figures in our calculator. So we have here 80.25 times 2.2 plus 8.25 times 0.8 minus 11.5 times 1.2, all of that divided by 100, and that gives you 1.6935. So that's equal to 1.6935, which is basically in terms of pence. Okay, so that's 1.69 pence per carat. Okay, so that is the profit. So the profit is 1.69 pence per carat. And there we have the answer to part E, and we have now completed question number 3 from this paper. The other questions from this paper can be found at the end of this video. If you click on the link that appears in this area here. Other questions to do with histograms you can find by clicking on this link. You can subscribe to my channel by clicking over here. Top of the page, you'll have a card that takes you to other S1 papers. In the description, you'll find links to other papers. P1, P2, P3, P4, M1, also some IGCSE papers that I've answered. Thank you for watching, and see you soon.